Here is a problem that is relates to shear stress, and I am going to solve it. So the question is, figure shows, that means this figure shows the cross section of a beam like T-beam, and which is subjected to a shear force of 20 kilonewton, and said that draw shear stress distribution across the depth marking values at salient point. That means this is nothing but at neutral edges, and you have to draw a shear stress diagram. And for this, first of all, I have to find out the neutral edges. Where is the neutral edges? And we know that the center of this section will be the neutral edges of this beam section. So I will take the base of this section is this x-axis. So from here I will find out the centroid of this section. So here the calculation. So this will be the solution. So this distance I will take yt, just taking, and this will be the distance of centroid from this base, that means x. So here's the calculation, and the area of, here's two part, this part and this part. So area of this is 100 into 12, that means this area, and its centroid will be from the base x, so it will be 6 mm, plus here's the other one. So this area will be 88 into 12, and this centroid will be from here. So this 12 plus 88 by half, that means 44. So 12 plus 44, so this will be the CG of this part. So from here, and now here it will be yt into this 2's area. So it will be 100 into 12 plus 88 into 12. So yt will be nothing but this one, 100 into 12 into 6 plus 88 into 12 into, this is 56, and 100 into 12 plus 88 into 12. So what will be the value of this solution? So it is 29.404 mm. So the value, this is 29.404 mm from this x, so it will be 29.404 mm. So here the total value is 88 plus 12, that means 100. So this is 29.404, and the other part, this part will be 70.596. Now I am going to find out the moment of inertia for this section. So what will be the moment of inertia? That is I is equal to bh cube by 12. So from neutral axis I will be calculated, this is the neutral axis, and this is from x is 29.404. so I for this one, so bh cube, so b is 100 and h is 12 cube by 12, plus this is not at the centered or neutral axis, this centered is not in the neutral axis. So you have to find out AD square. So AD square will be 100 into 12, and D will be this one centered is 6 from here, and neutral axis is from here to here is 29. So you have to deduct 6 from 29.404 minus 6. So you can understand that this is 6, and you have to find this distance from neutral axis. So this is 29.404 minus 6, it's square. This is nothing but it is a bh cube by 12 plus AD square. So this is the A and this is D square. So you have you got from this one, and now you have to calculate this one. So this will be plus this is 88, and this is the B. So 12 into 88 cube by 12 plus here also AD square because its centroid is 44 and this is 29.404 from this x. So here's the 70.596 from here. Its centroid is 44, so you have to um, minus from 70.596. So A is the 12 into 88 and you will be deduct 70.596 minus 44. This one's centroid is square. So what will be the value? So the value is 21,00127 millimeter to the power 4. Now I am going to find out shear stress for different position of this section. So first I will find out shear stress for this section, for this one, for the flange of this section. So this is we know the shear stress formula is tau is equal to VQ by IB, and this Q is the first moment of area. So you know Q is equal to a y bar. So this A is nothing but this A is this area, so it will be 12 into 100. And what will be the y bar? So y bar is nothing but this is 20, from here this is 29.404, and this one's centroid is from 6, from this x, so you have to deduct 6 mm from 29.404. so 29.404 minus 6, so this will be the y bar. So you have to put this value here, and V is nothing but the 20 kilonewton that is given in the problem. So 20 kilonewton I will multiply with 1000, this converted to Newton, and Q is 1200 into 29.404 minus 6, that means 23.404, and I is the value 221,00127 into B is nothing but this 100, so this is 100. So what will be the value of this solution? This is nothing but 2.67 Newton per millimeter square. So this value I find for this flange, and now I will going to find out this bottom part at the same bottom part of this flange. So here if I draw the diagram, this is my T section. So here I found these values. So this is the shear stress diagram, and the value I found, this is 2.67, and now I have to find the value for shear stress is here. So in this point, what will be the value? This is tau is equal to VQ by IB, and here QY bar and y bar and a, everything will be same, but this b value will be changed. So this b value will be this wave thickness, so it is 12 mm. So here's the solution. This is 20 into 1000, this is v value, this is 20 kilonewton into this is this area is 1200 because 100 into 12 into this is the centroid position, so this is 23.404. Same calculation, just here this is moment of inertia, and this 100 will be changed to 12 mm. This is wave thickness, and this is just under the, just below the this flange. So here after calculating this we will get 22.29 Newton per millimeter square. So here the value will be jumped to 22.29 Newton per millimeter square, and it is also Newton per millimeter square. Now we know that the shear stress will be maximum at the neutral edges of any section, so you have to find out for neutral edges this section's shear stress. So at first you have to find for neutral edges shear stress, then you have to find that AY bar, that means Q value. So what will be the AY bar for neutral edges shear stress? This is nothing but this upper portions, Y will be the centroid, and A is for this section is 100 into 12, this one, so 100 into 12 into this one centroid will be from here is 29.404 minus 6, 404 minus 6. So I find for this one, and now AY bar for this one. So this one's distance, this is what's the depth distance from here, this one. So this is 29.404 minus 12, this is the depth and this is the width, so it will be in multiplies with 12 multiply with its centroid. So this one centroid is nothing but into 29.404 minus 12 by 2, because this one I am taking this one, this, that means here is 29.404 minus 12 by 2, so here will be the centroid. And now after calculating this, you will find the value of 29902.195 millimeter cube. So this one is the value of Q. So tau Na for neutral edges, this is VQ. So VQ is 20 into 1000 converted to Newton, and this Q value is 29.0195 and divided by this moment of inertia into the width is 12. So from here you can find out the value. This is 23.73 Newton per millimeter square. So the maximum shear stress is at the neutral edges. So if neutral edges is this, so here's the value, this is 23.73 and this will convert it to 0. So this is the solution of this problem. This is the diagram, shear stress diagram for this section and with this shear force.